Hi guys, so we're told to find the transfer function of this circuit using mesh analysis. So for mesh analysis, we first have to define our mesh current, which in this case would be this. So now we now do KVL around the loop. So it's going to be minus V in, right? Starting from here, plus because current drops across the resistor. Current across voltage across the resistor is IR. So in this case, sorry, let me change to small letter I. Plus now you see current across a capacitor is actually 1 over C integral of I dt. Plus current across an inductor is L di over dt. By the way, I forgot to mention transfer function is equal to V out over V in. So basically we need to find the voltage across the output, which is along this path, and then over the V in. This will be equals to 0. So then we need to find the transfer function of each of this. That is why this is here. So let me just enlarge this. So for the first one, R is a constant in this case. So we're going to be looking at this. So this in A is a constant in this case. And then this is representative of I. By the way, I forgot to write I is changing with it. Literally, current is changing with time. So in this case, if we have to make this into the Laplace transform to be minus V in S, because we're going to the estimate. I, in this case, is representative of this I of t. Let's assume it's like this. It will become R, then capital letter I of S. Now this integral, we can see integral along this place. So this will become 1 over S as usual because this is just a constant. Then this part will become I of S over S. So instead of X, we have I. Plus the I over dt, which is this, will now become this. But sorry, I forgot to mention in this case all initial conditions are set to 0. So in this case we get to ignore this and only take this. So this become L. So L is a constant. Then S, then X in this case is I, then S. So this is going to be it. So now you can make V in substitute the formula and you're going to get. So now this is simply going to be the formula. Now we now need to find V out. V out is simply the voltage across the inductor, which in this case is L di over dt. And remember, if you take the transfer function, it just becomes LSI of S. It's as simple as that. Now to find the transfer function, I'm just going to remove this out of the way. To find the transfer function, let's call it g of s. It should simply be equals to v out by v in. What is v out? Ls I s all over ris plus 1 over c is over s plus lsis. Now, the thing is, when you're working with transfer functions, you don't really want to be having negative power of s. Like, look at this. This is 1 over s, so it's going to be s raised to the power minus 1. So let's try and bring s to become positive. So we can multiply this entire thing by cs over is. See, you can simplify it however way you want. Just try and ensure that this s is no longer at the bottom. Once you do this, you're going to get lcs square all over RCS plus 1 plus LCS squared. Now you can further simplify this so that only S will be at the numerator, because usually that's how this kind of transfer functions look like. So you can multiply by times 1 over LC times 1 over LC. Again, the way I'm simplifying is not definite. You can simplify it however you want to. Just ensure that the end result is okay. So this will be R over L S plus 1 over LC plus S squared. So either of this is okay. So basically this is just the transfer function of the circuit. Thank you for listening.